Okay, hopefully people can hear me. Great, early start, so thank you all for turning up and filling the room. Today I'm going to be talking about breaking batch and ultimately why data streaming is allowing a new paradigm of looking at data in your organization. And just to briefly introduce myself, I am Alex Stewart. I'm a senior solutions consultant at Confluent. For those who don't know Confluent, our founder, or our founders, were the people who helped invent Apache Kafka over at LinkedIn over 15 years ago now, and formed a company around that to, at this stage, build ultimately the leaders in building out the data streaming space with Confluent and for the SaaS service Confluent Cloud. And although I'm talking about how I should break batch, my history comes from 10 years ago. I was a mainframe engineer. Like, I lived batch, a big, scary black box that absolutely everything went into, and you had to wait to get that data out. So just a little bit of fan service for anyone who saw the title and thought this might be a Breaking Bad talk. I really like Skylar's quote from, I think it's season 5, is it? Yeah. From season 5 of Breaking Bad, where Walter was absolutely killing it. You know, he's cooking whatever it was, meth, and he was getting very successful at it. And they reached a point where Skylar ultimately had to give up counting. There was just too much happening, too much coming in. And although your industry might be slightly easier to explain to the authorities than Walter White's was, there's a high chance you're having a similar problem in the data space. The velocity of your data is ever increasing, and wherever you started, you know, with that basic infrastructure, you're probably starting to see you're hitting those bottlenecks, hitting those challenges of the approach you have. You can't simply go to your big storage locker and count those dollars at the end of the week anymore. And that's really been driven by how the world around us has changed. Virtually every industry has been disrupted and shifted because we've begun addressing business as software. You know, customer experiences have had to be completely reimagined. If you think about something like booking a taxi, you used to call up a taxi rank, they would look in probably a physical book, they would check and see that 2 hours ago their driver said he would probably be free at maybe 6 p.m. You live half an hour from the taxi rank, so hopefully the taxi driver can drive there in time. It's going to be a half-hour drive to the airport, so maybe that driver is free again by 7 or 8 p.m. But that doesn't work. Think of all that lost time in that business case. That driver could get stuck in traffic. That driver could have been free from 5, or I could be free as a passenger from much earlier. And we've seen this fundamental shift in the expectations of our customers, in the expectation of the rest of our business, for how we work as more and more things have become software, and we've shifted to this digital-first paradigm. You're probably not queuing up at a bank on Saturday morning anymore to cash your checks. But the big problem is that as that software and business paradigm shifted to moving to real time, the underlying data paradigms potentially didn't change, especially if you exist in a long-standing business. And a lot of that happened because of the relational database, the bread and butter of building a data system. Its foundational role in any architecture is to store data. Clues in the name. It's the base where everything will go. And it's going to keep it there at rest. It has no notion of how to interconnect or react to things that are happening elsewhere in the business, because it is fundamentally waiting to be asked. And that was fine when I had my taxi rank and it was just a piece of paper and I could go and ask a question. But then maybe we built an app, so that app had to be able to communicate at the speed of the customer. So I used something like a messaging service to write to that database as quickly as possible. And maybe I had to build a custom integration on the front to bring some data through. And that messaging system is fast, but it's static, and perhaps slightly more worryingly, it's transient. So when I send that message from my application to the database, it's gone afterwards. It's ephemeral. It stops existing. And so my operational system has been accelerated, but it's still seeing a bottleneck of sort of value in that underlying data. It's simply waiting, again, for something to happen in the database. And that operational domain then has a second issue, that it turns out the rest of the business needs to know what's going on. How many people are booking our taxis? Now, I don't want my analytical system interrupting my production business system. So what I have to do is wait. Maybe it's the end of every hour, the end of every day, or the end of every week. I run an ETL process that I know won't interfere with my database. And then I send that over to my data warehouse, where maybe I have a data mart that the rest of the organization can consume from for their business reports. But you can probably start to see a challenge here, that if I want to send this data back to my software application, back to the operational domain, that data's stale. That data has no context to where the application started, because the message in the middle was ephemeral, it died. And my feedback cycle is ultimately flawed and brittle and complex. And this was just booking a taxi. The problem is that as we've become more digitized in the products we're building on the operational front, our data systems have become more complex as well. Because it turns out my taxi booking app also needs to have a payment app, which has its own database. And now suddenly I have more data going to my data warehouse. And I potentially end up with hundreds of databases or dozens of data warehouse tables that people need to access. And then our app isn't scaling very well, so I make this a microservice. And then the microservice means I now have thousands of apps that need to access my database and need to be able to scale and need to be able to communicate. And then we acquire a food delivery service. So now I have another line of business with even more data and even more apps, and we're still having scaling problems. So I look across here and I see a couple of different cloud service providers, and I think, that's great, let's move some of that data to the cloud. I've not simplified anything here. I've made it significantly more complex. And as soon as I want to get data from my application in my line of business where I started over to the cloud, I'm probably going to end up trying to repeat what we had on the slide before, that messaging queue going to my database, and then my ETL tool publishing to my warehouse. And I'm going to end up with spaghetti. It's complex, and it doesn't really allow me to cut across. Ultimately, I'm going to have built a web of point-to-point, brittle interconnections. And this is where batch becomes, a real pain. Batch kind of encourages me to have data silos. I talked about my career starting on the mainframe, and we used to take data from all of the banks. They'd send it overnight in a batch job. But we have to wait on that bank to prepare that data. We can't calculate a credit score until Bank X has sent that information in. So we're always waiting as the data processor to actually receive that data. And there's a chance that if someone does something after that batch process, that could have been a monumental shift that I simply didn't capture. And I begin to lack governance if we figure out a way of speeding this up. If someone's going to build a point-to-point connection, how do I manage thousands or tens of thousands of those? And I have to worry about stale data along the way. It's going to hinder my decision-making, it's going to hinder my ability to innovate, and it's going to hinder my ability to find more insight at the pace that my customers expect. And that's why we believe at Confluent that there's fundamentally 5 better principles for building these data pipelines. Goes without saying, the core tenet of that is streaming. If I can continuously capture what is happening, and I move away from processing in batches, then I can begin to think of this like a nervous system, a real-time, interconnected, interlinked system where processing doesn't just happen immediately, but it happens continuously. Where I can set the rule set of how that's published, but then I know when I'm receiving this that I'm not getting data that is out of date, that it is actually what was happening in the business at that time. Now, the nature of moving towards streaming is that this will naturally decentralize. When I'm no longer bottlenecking around a warehousing team or a data team, I'm going to end up pushing some of that responsibility out to the domain that created the data, maybe out to my taxi booking app, like I was talking about earlier. But that's a good thing. I no longer have a data team managing what that data looks like and how it's consumed or thought about. I'm actually shifting it to the experts, the people who built the application, the people who have the domain expertise. Although a nature of decentralization is that I should be governing this and making sure it's discoverable. And of course, the final part of this is figuring out, once I have discoverable streamed data, how do I make this accessible? So it is going to have to be declarative. I have to find ways of repeating patterns. Can I make sure that it's easy to get data out of a data warehouse or out of a relational database? Can I show the health of that flow so people know where to go in and retrieve that data in the correct way? And can I make that accessible to everyone in their language? I've seen quite a few name tags today that have the word data scientist or data engineer on. Maybe you're more comfortable with something like a SQL-based language, but there's going to be others in the organization, maybe building out our microservices, who would prefer this in an actual programming language. And there may be others who simply need to scrape this data for some other reason, who'd be more comfortable with a GUI, a web interface, or even pulling this down via a CLI. And what that begins to allow is a much more scalable architecture. And what ends up happening is we actually find organic growth of that data happens in a company as they move towards streaming. Because there's no longer this brittle web of interconnected services that have no context of one another. Instead, a single sink, a single place everyone can go and know how they can receive that information, we begin to see some pretty monumental shifts. One of my favorite examples of this is AO.com. For people who aren't familiar, they're a really big e-retailer who sells household electronics and white goods. And you can probably imagine at the start of COVID, they were starting to see massive growth. People are locked at home, so they're going to buy a nicer TV, or they're pretty much required to make sure their fridge is working. So they adopted Confluent Cloud, and they began moving away from their old sort of static data at rest based architecture to one built around streaming. And immediately they saw this opportunity for a proliferation of that data. Teams coming on board to the platform with use cases they hadn't thought about. Because now there was an easy, accessible, and trustworthy way of actually receiving that stream of data that someone could pick up as a history. And it allowed their teams to be a lot more agile with their data and move much faster because they were no longer being locked in by a central piece of the organization. So when we think about this, why does the stream allow data propagation? Well, the alternative to this, I've mentioned microservices a few times. One of the ways we may traditionally propagate data in something like a batch-based system is maybe having APIs. So I can call out to a specific publisher and ask them for a piece of information. But if I reach out to that service and I collect the last half hour of information, and then I have to wait another half hour, If I myself am creating a data product that needs to be used elsewhere in the organization, it's just like cooking a meal with, spoiled ingredients. The end dish is going to be ruined because the ingredients I put in were out of date. If you're building data products in your organization, you want them to be real time, because what's upstream is going to immediately impact what you can build downstream as well. And although this naturally enables real-time data, it is a stream, and we recognize that real-time data definitely provides value to a lot of bits of organizations. That's not to say this is only for real-time use cases. Because if you think about it, one of the benefits of building with Confluent and building on Kafka is that we have a historical, immutable, and replayable log of our activity. These streams are persisted and they're replayable, so they let me capture both real-time and historical data in one setup. If you've read about the Kappa architecture, you may be familiar with this sort of idea, that where we used to stream fast data and forget about it and then drop data at rest, it meant we ended up having two very separate systems depending on what we wanted to do. I may have a batch of deep information and then just an event trigger happening on top. Whereas if I approach this with a stream where I look at the Kappa architecture, it becomes very important because I don't know who my consumer is going to be tomorrow. I may not even know who my consumer is going to be today of that data product I produce. If I was just querying my data at rest, it might mean someone doesn't know the context of what happened before. So for example, if I'm maybe building a machine learning model, I probably want to know the history of someone's account activity before I build out a fraud profile of them. Because if I just look at the current state, I don't know what they've been doing before. So having use cases where the data is required to have some history, I gain this extra context. And I have this added benefit as well, that I now have an auditable log. So again, if I am building out something with machine learning, I have a nice extra benefit that if my model looks a little bit off, I can jump back to step 1 and replay up to step 7 if something that happened in 8, 9, and 10 started to cause a problem, while still letting a separate real-time consumer read from the same source at the same time. And just because it's kind of the buzz of this conference, I think this is particularly relevant if we look at it in some of the recent changes that we're seeing in the data space. One of the big areas where you see batch being very popular is obviously in the world of model building, because I do have potentially thousands, millions, or even billions of data points that I want to collect even from my enterprise data store, maybe my data warehouse or my data lake. I want to shift them all into my processing library, where I'm going to do some iterative processes, maybe some custom training or feature engineering. And this was all pretty slow. And part of the reason we used batch is that training was really expensive. So that meant at the point of inference, the point where I say, hey, is Alex's recent transaction going to be fraudulent? I have to look at that, and maybe I'm streaming data through in real time, but I'm not going to do a lot of real-time enrichment. In comparison, as we've seen this move recently towards foundational models, how they're going to be used differently in businesses, suddenly that real-time data access becomes much more of a focus. I'm going to let some other company build a foundational model that allows me to communicate naturally or detect objects in an image, whatever my business use case is. And my value add as a prompt engineer, as a data engineer, and as a business actually happens at the point of inference. And that means that if I can take that base model and I can add my business IP on top of it, I'm going to want that in real time. Like, is this user doing something that seems a little out of place? Well, I can prompt that engine and then stream through that up-to-date data of their activity to better understand what's going on? Or can I allow a much more natural way for our customers to communicate with our data infrastructure, where I'm sending that third-party foundational model to do the research and reach out to our APIs, and then I'm building the inference layer on top, which has those controlled rule sets, and allows me to stream information to the inference model as well, to keep that all up to date. And this ultimately comes down to figuring out what the rules should be of building a better data streaming architecture. The first of those is recognizing that data at rest and batch processes certainly aren't going to die. They're going to be here for a very long time, and they still have their valuable use cases and areas. So where can I connect to those? Where can I enable streaming in a piece-by-piece way? I want to be able to continuously stream out of a database. They're ultimately built on having these logs of information as well. They just present that as static data. So once I've pulled that data from my operational domain and began building a stream, I do want to make sure that's accessible and governable. So building out using things like Confluent's schema registry and stream governance toolset that allows me to figure out who can access this data and how much information I'm going to give them about it. But also take advantage of things like stream processing, whether that's with Flink or Kafka Streams or other services that actually allow me to build a better data product. One of the benefits of moving towards streaming is if any of you are trying to buy the new iPhone, I bet you'd be really annoyed if it had last year's cameras or last year's chipset in it. There's no point providing a real-time data product that's still pulling stale data. So as I build out my streaming profile, I can make sure that all of my systems can talk to each other with the most up-to-date and relevant data that provide a true real-time data product. And that benefit of having that log that can be consumed by multiple sources at the same time means that I can also multicast this information as well. If you think about some of the use cases that you might have with transaction data is relevant to me as a bank for figuring out how much money I have, but it's also relevant to my fraud team, and it's also relevant to my customer experience team. And where I can multicast that out, I'm going to find repeat value in my organization. And most importantly, where that sharing takes me back to an analytical domain, this also enables me to send back to my system of record, once again in real time, and enrich my operational domain as well. And that ultimately allows me to go from a world of data chaos, our spaghetti diagram that we had before, to collecting my sources, be they traditional databases, be they SaaS tools like my CRM, be they monitoring tools and MQTT, IoT tools. Have my systems in place to process and govern that data to make sure we're still providing high quality data products. And then find those multicast use cases, inventory, payments, fraud, and so on, that I can share across the organization as they're needed. Because that's going to ultimately mean that I can start to address those challenges we looked at the beginning, where I can bridge the data divide, bring the operational and analytical domain much closer together. If you have a chance today to go to a talk on data mesh, you're going to hear this topic come up quite a lot. By having that stream that's accessible, multicastable, and most importantly, historical, I can massively speed up my time to market because people know that they have the ability to go and consume that data. And I can do all of this in a way that's built for my developers and for my data teams while still maintaining trust and compliance. So as a closing example, Afin Huang are a large cap asset manager out in APAC. And they followed quite a similar path to AO, where they were starting to see limitations on their data flow from traditional systems of records existing in databases getting to Snowflake. they couldn't build new applications because they were being blocked by that data flow that was ultimately not giving them insight. They'd organically scaled, they'd built that spaghetti diagram that we had before, and they were finding they were being siloed by their legacy systems. So when they trialed with Confluent and began to bring data in from their system of record, from their transactions, they immediately found that speeding up this process allowed them to go from having these records on a daily basis to having them within seconds or minutes. And as you can imagine, this opens up brand new use cases. Obviously, it's pretty popular in the asset management world at the moment to begin looking at regulated crypto activities and so on. So they've been able to address new use cases in that market because they can do things like know your transaction on a blockchain that simply wouldn't have been possible in their slower system, and take one of those streams like that transaction log to address new use cases like their customer onboarding, where they can do things like know your customer, fraud prevention, and anti-money laundering. So in closing, if you would like to learn more about what I've talked about today, I'm going to be on the booth over there that says Confluent for the rest of the day. If you would like to sign up to Confluent Cloud to build out a streaming pipeline like we've talked about today, please do scan that barcode and you'll be in with the chance of winning some Star Wars Lego. Otherwise, I'd like to say thank you, and I think I have 5 minutes left, so I'm also happy to open the floor up to Q&A.